let's focus for a few minutes so we can get ready for tomorrow's quiz. And this first one was like number 5. That's going to be on our quiz and on our practice quiz. You want to, first of all, move the 2 over so that you have 0 on the other side of the equation. All right, so I got x plus 2 over x minus 5 minus the 2 and then less or equal to 0. Okay, now in order to subtract the 2 from that fraction, I have to have my common denominator. So this is going to take the same denominator, and since it was a 1 originally, we just didn't write it. Since I multiplied the denominator by 1, I also by x minus 5. I got to multiply the numerator by x minus 5 also. So I'm distribute the 2, and I get 2x minus 10. And now I can subtract and make it 1 fraction. That's what I want. My goal is to get it to be 1 fraction on the left, a single fraction on the left, and 0 on the right. Right? Well, it will end up being, it'll end up being plus 10, yeah. It's going to be x minus 2x, which would be negative x, and then 2 minus negative 10, which is plus 10, like Drayden said. So we get 12. Okay, so that's my numerator and denominator. I use my numerator and denominator to get our critical values, we call them, so we can graph the solution set. Okay, so I want to make my number line for my graph. And what's going to make the denominator equal to 0? 5. Right? And that's going to be on here, this side. And what's going to make the numerator equal to 0? 12, right? Again, you just said each one equal to 0, but I think most of you can tell that it's 5 and 12, right? In your head. Any problems with that? Connor, are you with us?
Soaking it in.
Okay. So remember, the 5 can, the denominator can never be 0. So I can't never actually equal 5. So that has to have a circle on it. So when you have these fraction ones, number 5 tomorrow, the number that makes your denominator 0 must have a circle around it, not a dot. Now, since this is less than or equal to, I can have a 0 on the top. So it's okay to have a solid dot for the numerator. Okay, so that's part of it. Now, we pick numbers from each section of the graph to figure out where we draw our arrows. So I'm going to just pick 0 here because 0 is really easy to work with. In the middle, I'm going to pick 10. But it could be 6 through 11, right? 6, 7, 8, 9, 10, or 11. And then for this side, I'll just pick 13. Okay? So doing the left side of 5, using 0, 0 plus 2 is 2. And 0 minus 5 is negative 5. Is negative 2/5 less than or equal to 2? Yeah. So I would draw an arrow to the left because it worked. For the 10 plus 2 would be 12. And 10 minus 5 would be 5. And that's 2.4. When I write it as a decimal. Is 2.4 less than or equal to 2? No. So I wouldn't draw an arrow or a line connecting those. You can put a little X if you want. And then for 13 plus 2, I get 15 for the numerator. And 13 minus 5 is 8. And that is 1 7/8. Is that less than or equal to 2? Yeah. So I would draw an arrow to the right of the 12 also. There's my graph. So I think some of you forgot you were supposed to pick a number from each section of the graph when you do the fraction ones, number 5, and the quadratic ones, number 4. That's how we have to figure out where to draw our arrows. Questions? So we hadn't done one like that, since last Friday, so I thought we'd do another one just to make sure we understand. Number 1 for our practice quiz is just a basic inequality. Got an x on each side, so we're going to get the x's together. So I'm going to take the 3x over. I'm also going to take the 4 to the other side, so the constants are together. So I get negative 2x on the left, the 4's cancel, greater than, the 3x's cancel. 12 divided by negative 2, so x is less than, because I divided by negative 2, negative 6. So then I'll graph it, negative 6, negative 7, negative 5. There's no equal to, so it's a circle around the 6, negative 6. Less than would be to the left. So there's our solve part. X is less or equal to 6, and our graph part. Make sure we do both. Questions? Simple, right? Right, Lexi? Lexi and Lexi got there? Mm-hmm. Number 2 is a compound inequality. And we have greater than or equal to. So when it's a greater than, it's an or problem. So when it's done like this, I like to, instead of writing both problems, I like to just do both at once. So I want to get this x by itself in the middle, so I'm going to add a 1 to the middle, to the right side, and to the left side. You got to do it to all 3 sides. I get 11, greater than or equal to 3x, greater than or equal to 1, and then divide 3 by the middle, left, and right side. So you can leave it 11 thirds or 3.6 repeating. And you can leave it 1/3 or 0.3 repeating. Decimal or fraction, either way is fine. For some of you, I think it's easier if you write it as a decimal and know where it's at. So then we make our, and I've got 0, 1, 2, 3, 4, just to see where those are at. So 3.6 is here, it's greater than or equal to, so solid, so it's between the 3 and the 4. 1/3, 0.3 is just past the 0, between 0 and 1, solid dot again. And this is saying that the 3.6 is bigger than the x, so we would be going this way, because 3.6 is bigger than the numbers to its left. And this is saying x, the numbers are bigger than 1/3, so that one goes to the right. Okay? Remember, this is an or problem because it was greater. Right? What happens when an or problem goes towards each other? Because it's one or the other. That just keeps going in that direction, and this keeps going in this direction. So really, technically, it's one of these. Anything would work. If it was an and, then it's just between the two, because that when it's an and, it has to work for both. So it's where they overlap. But if it's an or like this, and they went towards each other, really it's all real numbers. So that's a little detail that maybe didn't happen in the homework that we did, but that's something we should realize. Usually the ors go opposite direction, but this one did. Okay? And if you pick any number, it's gonna work one side or the other. You know, if I use -2, -6 minus 1 is -7, that's less than 10, right? If I pick 12, 3 times 12 is 36, minus 1 is 35, that's bigger than 0, right? So it's one or the other. Questions? Okay. Number 3, absolute value is also 2 problems, remember. Don't forget, every year I get a few kids forget there's 2 problems here. Gray Tor again, so it's an OR. 2x minus 1 greater than 4 is the first problem. And then 2x minus 1 less than -4. So we change the inequality symbol and the sign of the 4. And then we do both problems. So we're going to do the same thing in both. Add 1 and divide by 2. So you could leave it 5 halves, or you could write the decimal 2.5. Here, add 1 and divide by 2. You could leave it -3 halves or -1.5. We didn't divide by a negative, so we don't have to switch the inequality symbols. So when we graph it, -1.5 to the left and 2.5 to the right. There's no equal to, so they're both circles. Greater than 2.5 is to the right of it. Less than 1 and -1.5 is to the left. So that's usually what happens with the ORs. They go out in the direction. Did we remember 2 problems? And remember, you switch inequality symbol and the sign. Don't switch what's in between the 2. In between the absolute value sign. It's still 2x minus 1 for both. Questions? You ain't vote, right? No problem. You can do it. All right, number 4 and 5 are a little bit tougher in that the graph part, we got to pick numbers from each section. So this is a quadratic. First of all, make sure the 0's on the right. If it's not, move everything to the left. It's on the right. And then factor. What's it factor, Logan?
3 and 2.
Good. X plus 3 and x plus 2. Okay, so my critical values are what, Lexi Ortman?
What?
What are my critical values then? What makes this 0?
A -2.
Good. What makes that 0?
-2.
Good. Those are my 2 numbers on my number line. Since it's just less than, no equal to, it's circles on both. And then I got to pick numbers. So I'm going to pick -4. I'm going to pick -2.5 right in the middle. And then I'm going to pick 0 over here. Okay? So when I put 0 in for x, I get 0 squared, 0, 5 times 0 is 0, 0 plus 6 will be 6. Is that less than 0? No. So that didn't go that way. -2.5 squared is positive 6.25. 5 times -2.5 is -12.5. And plus 6. So minus and plus 6. So I'm just going to add the 6's together. 6.25 plus 6 is 12.25. Minus 12.5 would be -0.25. Is that less than 0? Yeah. So we connect those. For the -4, -4 squared would be 16. Be black. plus 5 times -4, which would be -20, plus 6. So that's a -4 plus 6 is a +2. That is not less than 0. So I wouldn't go that direction either. Any problems with the graph part? Just picking numbers in each section. If it works, put a line or arrow in that direction. All right. Number 5 is like the warm-up. So we got x minus 5 over x plus 8 greater than or equal to 3. So we got to subtract the 3. It's like 3 over 1, so we get 0 over here. Going to multiply the bottom and the top by x plus 8, the common denominator. So I get 3x plus 24 when I distribute the 3. Now when I subtract them, I got 1x minus 3x, negative 2x, I got negative 5 minus 24, negative 29. So that's what I want it to be. I want a single fraction and 0 on the right. So then I can figure out what makes the top 0 and the bottom for my values on the number line. My critical value. And I get negative 14.5. For the x plus 8, you guys all know it's going to be what? Negative 8, right? Okay, so negative 14.5 would be further left than negative 8. Remember, on these now, denominator can never actually be 0, so the value for the denominator has to be a circle. It did have equal to there, so this one will be a solid dot. If it didn't have the equal to, that'd also be a circle. And I'm going to pick negative 15 here. I'll just pick negative 10 here. And over here, I'll pick 0 again. Okay, so remember, I'm going into the original problem for that. I'm running out of room there. X minus 5 and x plus 8. So negative 5, I got the blue one. 0 minus 5 is negative 5. And 0 plus 8 is 8. Is negative 5/8 greater than 3? No, right? Then negative 10 minus 5 is negative 15. And negative 10 plus 8 is negative 2. So that's a positive 7.5. Is that bigger than 3? Yeah. And then if the negative 15 minus 5 is negative 20. And negative 15 plus 8 is negative 7. That's a positive 2 6/7. And that's not bigger than 3. Less than 3, so it's in between again. Any questions on the inequalities? Making sense? All right. Cool. The last 5, 6 through 10, are what we did this week with the variations. Varies directly means what? Multiplication. Inverse means what? Division. Joint means what? Multiplication. Right? There's a couple of things for joint, right? At least 2. Okay, so number 6. Y varies equals K directly as X. So times directly as X. There's our equation. You're supposed to solve for K then. So y was 64 when x was 48. So we divide by 48. And that comes out to, what goes into 16 goes in there 4/3, the fraction. Or you could have 1.3 repeating, either one. Decimal or fractions, okay. Okay, questions? All right, number 7 had a combination. We have direct and inverse, right? T varies directly, so T equals K times the cube of R, that means R to the 3rd power, and inversely divided by the square root, so a radical sign of S, or as F, of S, yeah, inversely. So you can put that in there, you can do multiplication and division. And then it says T is 10, when R is 5, and S is 0.09. We just substitute in, and that's 10 equals K times 125 over 0.3. And you take the square root and cube 5. Square root of 0.09 is 0.3, and 5 cubed is 125. So how do I move to 0.3? Multiply. So multiply by 0.3. And 0.3 times 10 is 3. And how do I move the 125? We divide. So you could leave it as 3 over 125, that fraction, or the decimal is 0.024. Either one is acceptable, fraction or decimal. 6, 7, questions? Get those right? You don't even know, you're not even looking.
I'm taking this in.
You're just soaking it in? Yep. You did get that. You like it. All right, number 8. Word problem, the intensity of music is inversely, so I used I, is equals, inversely proportional is like varies inversely. So it's K divided by, for inverse, the square of the distance. Some of you forgot to square your distance. Okay? Any questions? All right, so it says the intensity was 1 when the distance was 8. So 1 when the distance was 8. Remember, it's 8 squared, which is 64. So how do I move that 64? Multiply, right? And 64 times 1, you guys don't need a calculator for that, do you? All right. So that's not the problem. Now we're not done. There's a second part. What was the intensity at a distance of 32? So I equals 64 for K, 32 for D, but remember, it's 32 squared, not 30, no, it's not, the answer is not 2. That's 64 divided by 32. It's actually 0.0625. Questions? Again, don't worry about watts per square meter. You don't have to worry about the units. It's not that intense, right? I don't think. All right, number 9, the cost of a concrete patio. So C for cost, or for concrete, however you want to do it, varies jointly equals K times, and remember jointly there's at least 2 things you're going to multiply. jointly as the area of the patio, so I use A for area, and the depth of the patio, I use D for depth. It costs $500 for a patio. When the area was 80 square feet, you just write the number, you don't need the feet squared is just the units, and a depth of 4 inches. So 80 times 4 is 320, so I'm dividing by 320 to solve for K. Zeros cancel, and dividing those by 2 is 25/16. The decimal for K was 1.5625. I just left it as fraction. So find the cost. Oops, not 12, 25. So 25/16 for K. The area is 144 square feet, so 12 by 12 patio, and 6 inches thick. All right, or depth, deep. So we multiply all those together, and it's going to cost us $1,350 for that patio. If you made a mistake, did you catch what you did wrong? That's the main thing. I know a few of you have made a few mistakes, but that's okay. As we go over it, we're fixing it, right? And number 10, the last one. The range of a projectile is directly proportional, so I used R for range. Directly proportional times, don't forget the K, the square. Some of you forgot to square the velocity. Some of you just had times V. Great.
For the last one, I put 1.6 around it.
Oh, so you got a little different price, huh?
Yeah.
Yeah.
Would that be considered wrong? Or-
No, as long as you showed your work, I can see what you did. All right, so it says a motorcyclist can make a jump 140 feet coming off the ramp at 60 miles per hour. So the range is the 140, how far he went. And 60 is the velocity, that's the speed. And remember, it's 60 squared. That's where I saw some of you made a mistake, you forgot to square the velocity. 60 squared is 3,600, so I'm going to divide by that 60 squared. So I figure out my K, my constant of variation. The zeros cancel. 7/180 is the fraction. The decimal is 0.038, repeating either one you can use. So then it says, how far can they jump? Going 65 miles per hour. So what's the range then? So, I'll just use the fraction. And it's 65, and don't forget, it's squared. And it's 164 feet. Or it says nearest 10, 164.3 feet. That's pretty far, over half a football field. I think half a football field is 150 feet. That's pretty far. I don't know if I'd want to be on a motorcycle in the air that long. Belush might want to. Or Marcus. How about you, Clay? Do you ride motorcycles or 4-wheelers? No? Questions? Simple, right? Right, Hoball? We're going to ace this first summative grade of the second 9 weeks. Debatable?
Yeah.
Come on.
Debatable.